In this video, I'm going to see how far we can push flexible filament on bowden printers, and I've got a couple of different filaments to show you as well. Let's go. Before we begin, I just want to catch up with where we are at with TPU after my first two videos on the subject. In video 1, I explained that you can print standard 95A TPU on a bowden printer like the Ender 3 series with very little issue if you do some initial calibration tests first. In video 2, I went a bit further than that by testing if you can improve the quality without increasing the failure rate, and we ended up with a few key premises. Firstly, we need to think of TPU in terms of pressure rather than print speed or whatever. We are pushing an elastic material down a tube, and so we lose that almost 1-to-1 ratio of movement at one end of the tube to movement at the other. Pushing at one end increases the pressure at the other end. It doesn't necessarily move the filament. And this causes the molten material to be extruded out of the nozzle as and when it pleases, not necessarily when we're actually pushing it. Secondly, we discovered by accident that there's an optimal speed. Presumably, having thought about it since then, it's probably more like an optimum flow rate. And we should print at around this kind of flow rate for the best finish, and this is actually higher than we may have been led to expect. Or is it? And finally, related to point 1, this goes completely against the grain, but it continues to be true in practice. When you have constant extrusion over a long period with an elastic filament, you build up the pressure, and most failure modes with this filament type involve the pressure becoming too high, which, in plain terms, either the wheels of the extruder will slip, or worse, the filament will eject from its proper path and then the print will fail completely. Both of these failure modes can be mitigated by a regular reset of the applied pressure, or, as we normally call it, retraction. So yes, retraction is actually not just possible with flexible filaments on bowdens, it's actually beneficial, and I would go as far to say it is necessary. So now we're up to speed, let's move on to some new exciting stuff. In this episode, I want to explore the limits of bowden as much as I can, for which I need a fair few types of filament. It turns out that flexible filaments that aren't so-called 95A TPU are pretty hard to get hold of here in the UK. So this is why I worked with Wedge 3D for this video. If you remember, I mentioned Wedge 3D in my PEI bed video, which was a contentious one, but let's not talk about that. They reached out to discuss how they could help with this video, and they managed to source for me a new type of filament that I'll show you in a bit. But they also provided me with a ton of samples to test in order to get the results that I needed for this video. There's also a link in the description to a voucher code if you want to buy some of the filament in this video yourself. You can check the description for that, and also which ones it applies to. So, let's talk shore hardness. When you buy your 95A TPU, the 95A is referring to a specific metric. A metric that describes the hardness of a material. It was invented officially by some guy called Shaw, and that's why it's called shore hardness. And this was about 100 years ago. The method of testing shore hardness is actually pretty simple. You use something proddy to poke at a specified sized lump of material, and you see how far it moves into that material when you apply a specified force to it. What you see here is a sample of Fiberflex 40D. I struggle to remember these names anyway because they're all fiber, filler, flexi, flex, and it does drive me insane. This is not 40A. If it was, you wouldn't be able to feed it into the extruder even, I don't think. Never mind print with it. It is 40D. So we have different shore hardness scales. Actually, quite a lot of them. A lot of different shore hardness scales. Luckily, most filament seems to be measured on either A or D. And I'll show you a diagram here comparing A with D. I get the impression it's kind of rough and you don't get a direct translation between D and A just because the way that they're both measured is different. But if we look at the tip of a D meter, this is the pokey thing that goes all the way to the tip. It's kind of like the end of a pencil. But the A is like the end of a pencil after you've blunted it. It's completely different shape. So that is why D is on a different scale to A. Oh, and the mass you apply to a D measurement is higher too. I do feel like for a lot of A-rated materials, if you use the D probe, you'd probably poke a hole all the way through the test piece. So, I guess we can rank some flexible filament. I have here your standard 95A filament, and yeah, I'm doing air quotes. It's probably close enough to the nearest 5 or so. I've then got 40D, which is probably about equivalent to 87A. So it's a fair bit softer than 95. It's 8 softer. And we also have 30D, which is about maybe 78A, give or take. I'll put this on screen because it's all very confusing. But what's evident is that they don't match perfectly between D and A, because if I bring in this Recreus Filaflex that I've blagged off a mate, this is 70A, and it is so much softer than the 30D. The 70A feels like pants elastic, and I'm serious. So which ones can we print? Well, all of them, of course. I mean, this is what I do. I will confirm that we can print all of them on a decent or even basic direct drive setup. But bowden is another matter entirely. We need to find where's the line, how far can you push it? Before we do that though, you might be wondering why I have a tray full of printed blocks of these samples. Well, I'm actually waiting for something to arrive. Hang on. Cheap tricks, they never get old. This is a Shaw Durometer. It's a Type A. It looks really cool. It's pretty cheap, but it also seems to work just fine. Let's test it. I know some of you really like my music, so I will shut up and let you listen to it. I thought that was pretty cool. I guess they are pretty accurate with their ratings after all. I did not expect that, especially for the various 95A filaments. They just don't all feel the same or print the same. It just goes to show that the Shaw hardness rating must be just one aspect of what makes a material appear a certain way. This 70A stuff though, it's either not 70A but 60A. I did double check and apparently it is the 70A one. I believe I may just be unable to extrude it, but it's reporting a lot lower than 70A. It's reporting as 60A. And that's something to bear in mind, that how you print this stuff massively affects how soft it is. Especially if you're using infill, these are all printed as solid blocks because you have to test them. So yeah, it doesn't really, the actual Shaw hardness doesn't directly correlate to the finished part that you've printed. You get the idea. I'll try and print this stuff again during edit on the Artillery's Titan extruder, which is the one that is recommended for this kind of stuff, I believe. So anyway, I made this thing a while back. It uses nearly no filament up, which is good because this stuff is expensive, but it also combines quite a few tests and failure modes into one model, while it's also printing at least most of the way before any of these happen. I'm going to use the Neptune 2S and Steve for the bowden tests, and I'm going to use Janet for the direct drive test. We have a pretty basic direct drive here with the Creality direct drive upgrade. I've covered this before, but let's just get on with it. 95A is not a problem in any printer, but I did observe in the Neptune 2S review that the Neptune is better than Steve at this TPU thing. But if you didn't watch that review, I concluded it's either the extruder or the Capricorn tubing that improves the TPU print quality compared to your standard Ender 3. And I actually maybe have an answer for you in this video about that. I did say I would test it later. 40D TPU is also not a problem for either Neptune or Steve. This is quite interesting. Steve is a bit stringy, but this is actually pretty normal. You would not know that this wasn't 95A TPU with that kind of print quality. Given that the 40D comes in around 85 to 98, that is actually quite a big deal. So it's worth pausing and thinking about that for a moment. We've gone from a platform of you need to direct drive to print flexibles and bowden can't really do it, to where we are now, which is being able to print softer than normal flexibles without a problem. If you're yelling, prove it by printing more at the screen right now, then just hold on, I do it later in the video. 30D time next, and the Neptune, no problem. And Steve is generally fine too. I mean, it's not perfect, but okay then. So at this point, we're thinking, do we need direct drive at all for flexibles? Yes, we do. This is the 70A, and it does not play at all with the dual gear bowden extruder on the Neptune 2. There's even less chance of it working on Steve's single gear Ender 3 extruder. It's quite funny to watch, at least so long as it's not jamming anything serious. It's tricky to get the direct drive to print this stuff too, actually, but here is a handy tip. If you're ever stuck with TPU, go and look at the manufacturer's website, especially if it's a big brand. They might actually have a ton of useful stuff, including printing parameters. They might have done that research. In fact, it's highly likely that they have. The parameters given didn't work for me, I'm guessing because my direct drive is, yeah, you know, this. But they got close. I basically halved the speed that they gave, and it printed perfectly, or close enough, to make this matte here, and that is a huge achievement for this kind of filament. Normally that would fail just because of the size of the thing, and you're doing a lot of long single runs, especially with the infill. This stuff is so soft, it feels like that weird stuff eggs have under the shell. I'm sure that's got a name. So what next? Well, I tried changing the tube on Steve to Capricorn tubing. This is genuine Capricorn, and it ought to print TPU better, or at least with less stringing, or at least something. But I didn't see that, not really. I kind of saw about the same kind of quality. It may have benefits, but I couldn't reproduce anything in this specific test. Of course, let's not forget it can print at a higher temperature than standard PTFE, so it's worth having anyway. I will leave it on so that I can print PETG, for example. So I would conclude that it's the dual gear extruder that's doing the work here on the Neptune 2S when it comes to improving the TPU print quality. Make of that what you will. This is MattFlex. It's flexible and it's matte. The name kind of gives that away. The sample I got didn't look that exciting until it was printed, and I noticed that it looks so cool and it prints so impeccably, even on a bowden, that I got straight onto Wedge 3D and I asked them to find me a whole reel of it. I had to wait a while for this as it's super new and it needed to be obtained from Fiberlogy themselves. Now that Wedge have got it, they've got it in stock on their website, and I guess that's probably my fault. I printed some really cool stuff with this though. This is for my bike handlebars. It looks really cool. And this is for no reason at all. In the future, I'll be doing all sorts of other kinds of grips with this stuff, like for camera lenses or tripods, as soon as I've got time to design them. So, one last thing on this episode. Why does 40D and 30D print so well on bowden? I've got no idea, maybe it always does, but I noticed something and I'm going to get the microscope out again. Any excuse to get the microscope out. And look what we've got here, ridges. This is not after the extruder, this is how it comes off the reel. Do these help? I can only imagine so. That's quite good, isn't it? Okay, so in terms of profiles in Cura, which is what I was using for this because I find that Cura is better for flexibles because of the granularity of the settings, I'll share the settings I've used in this video down below in the description. But one thing I want to try and convey in this and future episodes is that it's actually super easy. I know that word doesn't normally associate with Cura, but it's super easy to make your own TPU profiles. I'm not some kind of TPU genius, I'm just more familiar with the settings that matter. And these are the settings that matter, so it's better to tell you how to set it rather than just giving you profiles. There's another TPU video on the horizon because there's a lot more I wanted to cover, but I couldn't in this one, so look out for it. But I've got a pretty solid schedule, I will warn you. It might be a few weeks away. I've got Steppers number 2 to do next. There's a couple of product reviews that haven't arrived yet, but they can't wait when they arrive because then one of them at least is a new product. In fact, 2 of them are new products. So I'm going to try and increase my schedule a bit, which basically means make stuff quicker. No pressure on me, I'm sure. Some good stuff coming up though, so make sure you're subscribed if you aren't already. Anyway, that is it. I will see you next time. Thank you for watching.